Hello again, thanks for tuning back in. If you're here, you've probably seen the prior video on how to compute oscillation frequency of this horizontal bar sitting on a pair of rollers, and maybe you've also seen the video demonstrating a quantitative proof of the accuracy of that expression. The purpose of this video is to explain how to make one of these fixtures. Maybe you're a physics instructor or a tutor or an ambitious physics student, or maybe you're just looking for an alternative to watching grass grow and you need a new hobby. In any event, I have made 5 of these. This is the 5th and by far the most successful, and I'll explain how it's made, and I'll show some of the earlier renditions and point out some of the time-consuming mistakes and pitfalls to avoid. So this whirligig, by far the most successful, is made with a pair of 3-volt electric motors. They spin at about 100 RPM. They're battery powered. They came out of one of these, which is a zip note machine that dispenses a continuous sheet of adhesive backed paper. It's very much like a continuous post-it note, only a lot better. You can buy them online from zipnotes.com for $12, $13 a piece. I've got a bunch, and the motors are easily removed, and they are just perfect for this experiment. They're normally powered by a pair of 1.5 volts batteries in series. I've got them powered from an adjustable power supply that takes power from a wall outlet. The advantage being that the batteries don't wear out. And this adjustable power supply is convenient for proving that oscillation frequency varies with RPM. Cautionary note, don't feed these motors more than 3 volts for any amount of time because they'll burn out rather quickly. These are fragile and delicate motors, and after a couple of hours use, they'll probably burn out, and so you'll end up going through a number of them while you're experimenting. The motors are held in place by these little Stanley benchtop vices that can be found at a hardware store or online for about $12 or $15 a piece. The motors are sitting on kind of a bed simply made from a couple of pieces of plywood, and that allows for some fairly precise alignment of the rotors and very easy adjustment of the wheelbase, which is important for this experiment. The rotors very conveniently also have a groove in them that makes it very easy for the bars under test to stay in place. You'll need to do a little bit of experimenting to find bars that are suitable for your experiment. This bar, which is very useful, is actually a shish kebab stick. The white plastic rod that you saw in prior demonstrations is the long part of a plastic hanger. The long bars that you've seen are from a mattress frame, and the short little bar that you've seen in prior demonstrations, I just found that on the ground in front of a construction site. You can change the direction of the motors simply by reversing the polarity of the connectors until you have them set up so that they're turning in opposite directions and towards each other. So that's how the most recent fixture was made, and from here I'll tell you a little bit more about some of the others. Okay, fixture number 4, for which I had high expectations, turned out to be an abject and miserable failure. It's a pair of 110 volt erector set motors. I thought they would be just fabulous. Low RPM, adjustable RPM, fairly strong motors. Thought they would last a long time, wouldn't have to worry about burning them out or overheating. Um, but as you saw, the RPM of the oscillation is barely visible. What is an oscillation in this picture? Parts don't oscillate smoothly. It makes oscillations difficult to measure. There's just not a lot of grip or friction along the rotors. Plus, the motors vibrate a lot and they heat up. So, unfortunately, despite some high expectations, using these motors didn't work very well. A parenthetical note regarding the erector set motors, I also have a couple of these erector set 3-6 volt DC only motors that looked like they had a lot of promise, but unfortunately, even at 1.5 volt, the RPM is way too high. I'd like to find a few more of them, but they don't seem to be very easy to find. So, machine that didn't work, number 3, is made from a pair of identical cake mixers. As you saw while these machines were running, well, they look quite interesting. There's almost no oscillation that's visible or measurable. I believe that is due to a very smooth rotor surface and almost no friction with the bar. This was the second attempt at an oscillating whirligig, and not much of an improvement over the first one, which you'll see in a minute. About the only advantage of a cake mixer is that it is a readily made machine that has a gearbox that pretty much out of the box gives you a couple of rotors that turn towards each other. But that's about the only advantage. You were looking at the slowest RPM, a lot of vibration, and if that bar is oscillating, it's very hard to count. Okay, this is the first and original oscillating whirligig. It's made with the motor from a cake mixer. It's mounted in a wooden frame with the axles about a foot apart. The axles are driven from the motor using rubber bands as a pulley. The disadvantage of this system was, like all the other implementations using a cake mixer, is that there is almost no friction between the axles and the contact surface. It produces a very rapid oscillation that's hard to discern and hard to count. So that is everything that I can tell you about how to make or not make one of these oscillating whirligigs. The features that you're looking for are low RPM, low power, scratchy contact surfaces, an adjustable wheelbase, and kind of a low budget. This is the most effective machine of all of them, and it was also by far the least expensive. The issues to avoid are high RPM and smooth contact surfaces. I would also advise some cautionary notes for those of you who are thinking about making one of these things. I would strongly advise caution when trying to raid your wife's kitchen or your wife's vanity or her sewing room or her clothes closet to source parts. For some inexplicable reason, my wife was really unhappy when I took all her shish kebab skewers and cut them up, and she couldn't find any. She got a little displeased when I started to dissect some of her cake mixers, she had a few left over, but then I went out and bought a few more and took them apart and paid 2, 3 times as much as she did for the ones that were in her kitchen. Then for some reason she started getting irritated when I took all of her red and white and black nail polish for marking up the oscillation bars. Nor was she very pleased, and I took some of her favorite knitting needles and tried to use them for oscillating bars. I didn't scratch them up or dent them up all that much. And she didn't like it when I started taking some of her favorite clothes hangers and cutting them up. Sometimes the littlest things. But for a while now I've been living here in the garage, not because I want to, though it is kind of nice to sleep here. I just hope this all blows over before the cold weather gets in. In the meantime, thanks for watching. If you got questions or comments, let me know. Thank you.